Hello everyone. In this video we will try to solve two problems asked in GATE exam. First question here I am taking, it is y dash plus y is equal with mod of x, where the initial condition y at minus 1 is given as 0, and simply they are asking what will be the value of y1. This is the question. In fact, this problem was asked in GATE 2016's paper, and you can easily relate that this is a standard IVP problem, because this one you can write dy dx is equal with mod of x minus y, and this part is nothing but your f of xy, and this is your initial condition, isn't it? So you can simply relate this one. But this type of problems are not very easy to solve, because it seriously demands a different kind of treatment from you, as well as some logical approach is there. So follow each and every step, and if you find any difficulty, then use the comment section and give your comment or suggestion, whatever you want. Okay, so first of all, simply consider x greater than 0 case, then we will consider x less than 0 case, because here mod comes. That's why we are considering greater or 0 and less than 0 case. So in that first case it turns out to be this. Clear? After that, simply solve it. In that case you will find the integrating factor as e to the power x, and just simply solve it from your BSc's knowledge. You can easily just find the integrating factor, and just usual process, you will find that this one as your solution. That means yx, it is equal with x minus 1 a e to the power minus x. Nothing special. You are getting this one as your solution when x greater than 0. In fact, in the problem they have given us that x belongs to R, so x may be greater than 0 or less than 0, so we are considering both the cases. Now when x less than 0, in that case it turns out to be minus x, isn't it, this equation? And in that case we'll simply follow the steps. First of all, find the integrating factor, then make it exact, and you will find that this one is going to be your solution when x less than 0, b e to the power minus x. So this one is going to be your solution when x less than 0. Fine. Now observe it carefully that your initial condition, this was your initial condition, and it was given that y at minus 1, it is equal with 0. So whenever we are going to use y at minus 1 equal to 0, this condition, so we have to use this yx, because here we are considering x less than 0 case. Clear? So in that case you will have b into e, it is equal with 0, so you have b, it is equal with, I think, 2 by e, correct? And that immediately implies your yx, this one turns out to be minus 2 by e into e to the power minus x. Fine. Okay, up to that I think there is no problem. Okay, now here is the key point of this question. We are going to use the continuity at x equal to 0. In that case, the first criteria should be limit of yx Whose continuity? Continuity at x equal to 0. Whose continuity? Obviously yx's continuity we are going to use here. As x tends to 0 plus limit of yx, that should be equal with limit of yx as x tends to 0 minus. Obviously for the continuity it should be equal with y of 0. But we are going to use this one, then this part will immediately imply whenever x greater than 0 we are going to use this one. So it turns out to be 0 minus 1 plus a, and for the case of x less than 0 we are going to use this one. So we have this one minus 2 by e. Clear? Just simple calculation, and that will give us, I think, 2 minus 2 by e. This is the value of a we are getting after using the continuity property. Clear? So finally we have our yx. Whenever x greater than 0 we have this one here to the power minus x. So this one turns out to be this for x greater than 0. Clear? Fine. Now what is your question? Question is to find the value of y at x equal to 1. So simply find the value. 2 by e to the power minus 1. So you have 2 by e minus 2 by e square, y1. So now look at the options. Option 1 is the correct option. Fine. So this type of problem. So now come to the question. It was asked in GATE 2011's paper. A very simple problem. X dy dx, it is equal with, I think, y plus x square, where x greater than 0 and the initial condition y0, it is given as 0. Okay, this is the whole information given to us, and they are asking whether this IVP GATE 11 paper, it was asked whether this IVP has unique solution, no solution, infinitely many solution, exactly 2 solution, and all these things. And these are very trivial question for any competitive exam like NET, GATE, or any entrance exam for PhD. So look at how to approach this kind of problem. A very fundamental process we are going to use here. So whenever you have this kind of stuff in your hand, try to use your intuition first. That means simply divide both sides by x and you will have this stuff, and now you are already familiar with this, so there is nothing special to solve this differential equation. Find the integrating factor and you will have this kind of stuff. So just go with the flow, nothing else. X into 1 by x dx, x plus a, and please don't ask why I am doing all this stuff. These are all very fundamental things from BSc level. If you don't know, just please go there. There is a Raisinghani's book and read all the relevant topics and practice some problem, then come back. Okay, these are from. So you have for yx it is equal with x square plus ax. This one is your solution. But now use this initial condition. So you have y0, it is equal with 0. Y0, that means 0 square plus a into 0, that is equal with 0. That immediately implies 0 equal to 0 case. Always true, isn't it? But that was not your desire. Your desire to use that initial condition was to find a particular value of a, but you are not able to find the value of a, isn't it? So the conclusion from this part, it is we are not able to find A. Correct? That means your solution, it remains this one, where A is an arbitrary constant. That means A can take infinitely many values, isn't it? Just for this A, this solution yx, it may become yx equal to x square when A equal to 0. It may become yx equal to x square plus x when A equal to 1. It may become yx equal to x square minus x, and so on so forth. All the solutions are different. So what you can claim that? You can simply claim that the given IVP has infinitely many solution. Clear? This is the moral of this question. But suppose if in that problem you get a certain value of A, suppose a particular value of A you are getting, then for that particular value of A, you will get exactly yx plus yx equal to x square plus that value into x, this one as your solution. In that case, you will say that this IVP has unique solution for that particular value, isn't it? And if suppose you are getting an absurd kind of result from this using that initial condition, then you will say there is no solution. There are such kind of problems are also there. Take any standard book like MD Raisingenia or SL Ross and try to solve as many problems as you can. Then you will find various type of problems are there involving unique solution, no solution, infinitely many solutions, and all that.